It is. What? Just wait. All right. When you're dividing rational expressions, the only difference from multiplication is that there's a division symbol, right? However, when we learn how to divide fractions, if I had A divided by A over B divided by C over D, how were you taught to solve this? You do what? You flip it. You reciprocal. You multiply by the reciprocal. If your teacher was really cool, they would have said keep, change, flip. Right? You're going to keep the first fraction, change from division to multiplication, and flip the second fraction. After that, it just is multiplication. And the same thing that we did in part B is the same thing that's going to happen in part C. Okay? So these two steps right here are interchangeable. Whether you factor first or reciprocate first is 100% up to you, or you do it at the same time. Okay? But after that, all the steps are the same. It's just this right here. Okay? So again, when we are dividing fractions, we're multiplying by the reciprocal, right? So we have to keep, change, and flip. All right? That's all we're doing. So we're going to dive in and see what happens. All right? Wait. What are you writing? All right, so looking at the first one, here we have 16x squared divided by 3y squared divided by 8x divided by 9y, right? So we're going to follow keep, change, flip. So we have 16x squared divided by 3y squared. Instead of division, it becomes times 9y over 8x. We keep, change, flip. And then we just did the same thing that you should have learned in Algebra 1. Again, I'm a reducer before. So I reduced before. 16 and 8 become 2 and 1. Do we see that? 3 and 9 become 3 and 1. Yes? I have y squared and y. So I can take away a y to eliminate a y. I have x squared and x. I can take away an x to eliminate an x. And what am I left with? 2x and 3 makes what? 6x over y. That's not a y. It's not a y. And what can y not equal? 0.
And where do we put like multiplication division problems that turn into like a graph?
That numbers, there's multiple representations of numbers. All right, so here again, we are keeping, changing, and flipping. Okay, so I'm going to factor and leave the factors as they are. I'm going to change from division to multiplication, and I'm going to factor, but I'm going to flip the factors, right? All right, so the first one is simple, right? And what am I asking myself?
What adds?
Exactly. What's going to multiply to give me negative 15, but adds to give me 2? What are my numbers? What kind of 5 and 3?
5 and negative. No, negative 5 and 3.
Switch it.
5 and negative.
There you go. So I need a positive 5 and a negative 3. Okay, my denominator. How do I simplify that? I mean, factor that. Dots. Difference of 2 squares, right? Perfect. Good job, guys. All right, I'm multiplying. I got to remember that when I factor, I'm going to put it in its opposite place, right? X plus 1. Do I need to do anything to it? Nope. So it's going to go straight into the denominator. And then 3x minus 12. How do I factor that? GCF, greatest common factor. And what is the greatest common factor? 3. Perfect. And that leaves me with And then is this any different than multiplication? Nope. So now we're eliminating. Huh? I can eliminate x minus 4 only, right? I don't see anything else that can be eliminated. So we're left with 3 x plus 5 times x minus 3 all over x plus 4 times x plus 1. What are my restrictions? X can't equal what? There we go, -4 or -1, right?
Why is it all?
Because there's 2 factors left. So there's 2 things that can make this equal to 0. All right. On you. You got it. You got this. Yeah, you do. They're all GCF. They're all GCF, guys. They're all GCF. Okay. We can be delusional.
That's pretty.
Anthony, you left your ID here yesterday.
I know, man. I figured it was
What?
thanks, man. I was like, if anyone were to find it, they'd be doing right to it.
Yeah.
Thank you.
Welcome.
I don't have to pay for it, do I?
Yeah. They gave that up a long time ago.
I can't let it talk about work, like trying to charge actual students for an ID every day.
I did, my high school, it was $5 if you lost your ID. And you needed it as a senior and you can get off campus.
But like for temporary, but they're trying to charge people for a sticker. I think that would be.
Oh, no, you have to have a hard ID to get off campus at my school.
Yeah, but like last year they were trying to charge people for a sticker and I was like, no.
Well, the plan is, if they were consistent with it, you would get tired of paying $1.
Yeah,
There's people I've been giving, like, I'm on Thursdays, I do duty, there's people I've been giving temporaries to since September. So.
the girl is gonna realize.
Exactly.
Well,
Can't
the
realize
thing is,
it.
you can get 2 pieces in your back. Isn't really open to get like, you can't really get them if you don't have them.
You're supposed to go during your lunch.
Is the office ever open?
Yeah, but this one open.
They've been closed always. I think.
No, they're open. Are we ready to check?
Hold up, no, I got distracted.
Oh, my bad, my bad. I'll take blame.
Can you cancel out across the top?
No, bottom and top only.
Okay.
She said across the top. That's multiplication.
Oh, I remember.
You multiply something wrong. Yeah.
Oh.
I was like, you multiplied something wrong. Yes. I was like, oh, America.
Am I going crazy?
Nope. What'd y'all get? Yay.
I was like.
All right, so GCFing it really quick. We have 3 y minus 4 over 2 y plus 2. Yes. All right, keep, change, flip. So these are, remember, are switching their locations. So GCF here is 6 y minus 4. GCF here is 4 y plus 2. And what happens? Oh my gosh, all of these factors do what? They cancel out, 3 times 4 is 12. 2 times 6 is, what does that equal? 1. All of that became a 1. All right.
Why did it just write 1?
You don't know where the numbers came from or the data, so there's different reasons. All right, so that concludes our 3.5D.
Probably doesn't